Rounding special cases. Let's try another example with rounding. By rounding 1,955 to the nearest hundred. First step is to find 1,955 on the number line and label it. Notice we're going from 1,900 up to 2,000, and there's 100 units in between, so each dash represents 10. So if this is 1,950, then this would be 1,960. Well, 1,955 is right smack dab in the middle. So let's plot and label. So now that we have 1,955 plotted on the number line, is this number closer to 1,900 or is it closer to 2,000? Well, let's actually make our highlights here. We've been going from low up to that point is yellow. And then if we do the rest in green, which one of these is shorter? Well, the green is shorter, so it's actually closer to 2,000. So that's going to be the answer to this question. It's 2,000. So then what is 1,955 rounded to the nearest hundred? It actually ends up being 2,000. So what happened here? We had 1,955, and this 5 that we're looking at rounds this 9 up to a 10. So we had to put a 0 down in this place and carry a 1 or add an extra place value into the thousands. So this became or increased by 1 because of that carryover. And then the remaining numbers ended up being zeros. Let's take another look at how to round 1,955 to the nearest hundred, this time using the set of steps and questions that we've been establishing when rounding. So we have 1,955 and we put our pencil tip under the digit in the hundreds place, and then we look to the right at our 5. Is this digit 5 or more? Yes, it is. What happens to the digit in the hundreds place? Does it increase by 1 or does it remain the same? Well, because this is 5 or more, the 9 is going to increase by 1. But what happens when the 9 is increased by 1? It ends up becoming 10. So we could write it as 1,000. I'll write the original problem again. And again, we increased this by 1. So that means that we have 9 increases to 10. And then this extra 1,000 that is sitting here also needs to be dropped down, and all of the other remaining place values are zeros because the 55 ends up going away when we round, and then we can add these up and we get 2,000, which is the number that we found on the number line on the previous slide. So the answer here is 2,000. If we would have had any other digits remaining to the left of the number in the thousands place, those numbers would have remained the same, which is what step 4 was generally saying. So the final answer here is 2,000. Let's try another example. Round the number 5,995 to the nearest 10. First step is find 5,995 on the number line and label it. Well, if we look at our number line, we have 5,990 and then 1, 2, 3, 4, 5. Oh, it's actually labeled. I'll just draw another dot over top of it. So this is where 5,995 is located on our number line. Okay, so the next step is 5,995 closer to 5,990, or is it closer to 6,000? Well, now let's actually draw in our different colors that we've been doing to see which is closer. So there's the first part, and the second part would be over here. And if we notice, each one of these is about 5 units long, so it's directly in the middle. And when this occurs, because it's 5, the rule is to always round up. So therefore, it's going to be closer to 6,000. So what is 5,995 rounded to the nearest 10? It ends up being 6,000. Let's take another look at this example. Round the number 5,995 to the nearest 10. Let's start by putting the pencil point under the digit in the tens place. And then we're going to look at the digit immediately to its right, which is a 5. Is this digit that we underlined 5 or more? Yes, it is. So then what happens to the digit in the tens column, this 9? Does it increase by 1 or does it remain the same? It increases by 1. But wait a second. If I have 9 and I increase it by 1, it's going to end up being 10. Or if I have 90, because that's what 9 in the tens column represents, and I add another 10 to that, it's going to be 100. So then that's going to make the 5 in the ones column becomes a 0. This 9 in the tens column also becomes a 0 because we are going to end up having an extra 10, bringing it up to 100. And then the 9 in the hundreds column is also going to end up becoming a 0 because we're adding an extra 100 to 900, and that's going to round up to 1,000. So that's going to be a 0 there. And then the 5,000 is going to add 1,000 to that. So it's going to end up being 6,000 as our answer. If we would have had an extra digit in the 10,000s column, those numbers would have remained the same. We can also take a look at this visually using blocks. So here we have 5,995, and we're rounding to the tens place. So we look at the 5, we're rounding here. So we look at this 5 and we're going to round up because it's 5 or more. So I'm going to add an extra column of 10 blocks here. And when I do that, this ends up becoming a clean set of 100. And then these extra 5 go away. So then this extra set of 100 gets grouped with this set up here. So what used to be 1, 2, 3, 4, 5, 6, 7, 8, 9 hundreds now becomes 10 hundred sets, or sets of 100. So then this extra set of 100, if I was to group these closer together, they give you an extra 1,000 blocks. So that's how we end up getting 6,000 as our answer there.